The periodic table. Now there are a bunch of elements in the world where different substances. There's gold, there's silver, and also bronze, which would be when copper and tin together, that is bronze. So a bunch of substances. Some can be put together like copper and tin, that becomes then bronze. Or just gold or silver or platinum or something else. All these elements, they have to be sorted, and 109 are known in this book when this book was written. A few found since then. A few were found since then. Now, these 109 elements, they have to be sorted. They have to be sorted in some way. And the periodic table is the way to do it, which is a way which is often used to do it. And there was Dmitry Mendeleev, and in 1896 he published his idea how to sort them. He took every element which he knew about, wrote all the information down on the card, sorted them, and published it then, and that was his result. So all the elements down, 1, 2, 3, 4, 5, 6, and so on, all the elements, 109 down in these lists. These lists are the periods, and that are the groups. Let's like that. And they all have similarities, and someone who understands, is like that written in the book, how they are sorted there, can, by just looking at where they are written, know something about how this element will behave alone or with another one together. And now it is like that. There are different groups. There are the alkali metals, and then the alkaline earth metals, the transition metals, the lanthanides and austenites, and then the poor metals, the semi-metals, and the non-metals, and the noble gases. So all these groups. And they behave almost all similar if they're in such a group. So if someone understands it, they know it is written in the first group or the second group, that element will behave like that. It will burn at that degree, it will make then fire, it will react with other thing strongly, it will make something, it will shatter, it will make it going away, so it will make a solution out of it, how it will behave, basically. What will it do with another stuff? Will it be just peaceful there, or will it react? And for example, all these metals together, they have something similar things. Metals, they are solid at room temperature, a part of mercury for some reason. So solid, they conduct heat good. That is why if someone touches a metallic thing, it feels cold because warmth is going fast away. And other things, they are not like that. It goes not so fast away. Air, for example, is gas. And gas is not transporting the heat so fast, and also does not conduct the electricity so good. But metal does, and that is why cables are out of metal and stuff like that. So someone who understands it knows metal stands there and there and there, and they know out of that could be done a cable, or that stuff will react together with that, and so on. So something's there. How they are written there? Where is then written for carbon, for example, is 6 at the top. And then the C, then carbon, and then 12. The 6 means it has the atomic number 6. So someone could say atomic number 6 is carbon, or carbon has the atomic number 6. And that means that carbon is the 6th element in this list. There's 1, 2, 3, 4, 5, 6 somewhere there. And that 6 is the amount of protons in the nucleus. Such an atom has in the center of the nucleus, and then around it, shells, called like that. I don't think they're actually existing, but it's just called like that, shells, and on these shells are the electrons. So such an atom looks like that. In the center there is the nucleus with a proton in it by the atomic number carbon, 6. And then out of them, on these shells, however that now actually looks with these shells, there are now 6 electrons. So the same amount of protons has such an atom as electrons. And atomic number 6 says 6. Gold has whatever, 64, whatever. That means those 64 protons are in there, and the other thing. Lead has 79 or whatever, and there are now 79 protons in the center and 79 on the outside. And these shells were starting like their first shells of 2, and then there are 2 electrons are on it. So that is for hydrogen. Hydrogen has the atomic number 1, and then helium number 2. Hydrogen has now 1 proton in the center and 1 electron then on the shell. Helium has now 2 protons in the center and 2 on the shells. And that is why we are so far apart written, because the shells are already full. I think that is the reason. So it doesn't look completely like rows, because these shells are differently. The first shell can only hold 2 electrons, the after one's 8, and probably even more. And so they're not written like 1, 2, 3, 4, 5, 6, 7, 8, or 10, so 1, 2, then 3, 4, 5, 6, 7, 8, or something like that, and then more or less like rows. And all the one in the first row, they have 1 electron on the outside. And the last row, there they have 8 or full. It wasn't said directly in the book. They are the electrons been full on the shells. Now, and that has a lot to do with how they react. Some electron with one on the outermost shell. If there's 1 electron on the outermost shell, that can easily react with another substance as if there were 2. So it has an influence how many are on the outermost shell, because that electron can be lost or gained. 1 electron can be gained to an atom and lost. So where they are, tells when how they are reacting, because all the one in the first row have one electron on the outside. That one electron, which is where the outermost shell, so there's the nucleus with all the protons in it and neutrons also, and then all the electrons on the outermost shell, and all elements in the first group have one electron in the outermost shell. And therefore all these atoms in the first rows, these alkaline earths, have a similarity how they will react with other metals because they have one electron there. It's like a puzzle piece. That puzzle piece will fit together with south one who has 4, 3, 5 or 6 electrons in the outermost shell. And we're going always up. Every one further, one group further, or one row further, it's not said so directly here, has been one more. So one electron outermost shell, 2, 3, 4, 5, 6, 7, 8. So that is why there can be something read about how it all works. And maybe some interesting fun fact would be, the more protons are in the center, the more they're pulling in the shells. So actually the amount of atoms increases down the period with 15, 16, 17, 18, 19, 20 and so on, but the atom decreases in size because there are no more protons in the center pulling in the electrons on the outside. As a little fun fact. Now, and that is according to Susan McKeever's Science Encyclopedia book, written on the page 32 and 33.